I'm going to talk today about measuring HPC, why we should measure HPC and how we do it. This is the first time I've given the presentation in this format, which is the 25-minute version. It's normally a 1-hour talk, so let's see whether I've managed to cut it down to 25 minutes successfully. It will therefore be quite high level because we're running through it quite quickly. You will find that as I give the presentation, I keep self-advertising my tutorial at SC16. The reason for that is because that's a 3-hour version of this presentation that goes into all the full details. So I keep saying, in the full version, I do this. So I do apologize in advance for that. So the first part of the presentation, we're going to look at, or I'm going to talk about why we measure HPC. So if I was to ask a number of people in the room, why you measure your HPC systems, why you measure the use of the systems, why you measure your HPC services, I would be willing to bet that a high proportion of you will come up with an answer something like this. In other words, to justify the investment you've made in that facility. Personally, I believe that's a bit of a weak idea. Really, you should have justified your investment before you made it, not after you made it. It's a little bit late after you've made it. The investment should be fully justified beforehand. You shouldn't be wasting your valuable time trying to justify what you've already done because it's done. What you should be doing is using your valuable time, therefore your measurement exercises, to make sure you extract the most benefit from those decisions you've already made. In other words, to make sure the facility is delivering the most benefit, is being used in the most way. It's no longer about justifying its use, you've got it. The other reason you measure your HPC facilities and your HPC services is to help justify the next decision, to help build the business case for the next decision, to help make sure that the decisions you make next time are the right one, both in business terms and in technology terms. So looking at making the best use of what we have, you measure the system, how the system's used, you measure the service around it, the people, the support infrastructures, and all the rest of it, so that you can understand how the current HPC capability is used, both in pure utilization terms and so on, but also in terms of how it generates value for the business, so that you can optimize the usage of that facility, optimize the usage of that HPC service to maximize its impact on either science and engineering or business value or research or whatever the appropriate goal or metric of your organization is. Very often you're also encouraged, particularly in a shared facility, to try and optimize fairness as well, which is a mythical term and a grand dream for making things fair to all users. I'm going to make sure that I've got more of the facility than anyone else, at less of the cost than anyone else. But we always try for it. The other one that a lot of organizations have to play with and balance is innovation use versus production use of the system. So people experimenting with the system, trying new things, trying experimental stuff, doing stuff that hasn't been done before, versus those who are using the system for clear production work or clear production goals on the system, designing the current product or validating the current product or whatever it is they're using the system for. And trying to balance between those two things also requires a bit of measurement of the system and how it's used. On a day-to-day basis, certainly your users are doing this if you're not doing it at facility. You're also measuring the use of the system to understand how the performance of that combination of hardware and application software should be appropriately balanced to decide how many simulations you're going to do, what size of simulations, what resolution you can afford to run with, so that you can get the business results you need in the time you have available. And that guides also the development of the applications. You measure how well the applications perform on the hardware, and therefore it gives you some guidance as to how you need to evolve the algorithms of the application, what new science you need to put in if you need to make step changes, if you need to find different methods of solving the problem, and so on. This leads to this wonderful word that's thrown around, particularly in exascale programs, in HPC in general at the moment, which is co-design, which I'm not really a big fan of. If any of you have read any of my blogs on the subject, you'll see me getting a bit snarky with co-design. Either is an overrated buzzword, it gets thrown at everything, whereas anybody's doing stuff that we were doing all the time before, which is designing our applications with the hardware in mind. And the hardware design is taking some account of the applications that are going to run on them when they design the processors. All that stuff's always gone on. So I think labeling as co-design is just a little bit of marketing exercises. It also creates unrealistic expectations that the next generation of the hardware and the software are going to work together wonderfully without anybody doing any kind of tuning work or any of that, which is not realistic. And as I said, it could be considered to be business as usual as well. It's stuff we've always done. The other aspect I said about measuring HPC is measuring it for the future rather than for the past. Not justifying your past decisions, but helping to use the data on how the current facility is operated, how it's run, how it's used, and more importantly, how the value is generated for the business from the use of that facility. Using those measurements so that you can continue to make investments in the HPC facility with confidence that you're spending your money wisely. And this is what I'm saying about making sure your investment decisions are justified before you make them, not afterwards. And of course, you're also looking to get some more specific data to make sure that those investments are at the right scale, they're the right type of investment, they're the right type of system, they're the right type of investment, or balance between people and software and hardware and so on. And the other thing you might want to do is to make sure that the timing of those investments is correct so that you get maximum value into the business, either because you're trying to align it with internal project timelines within the company or expected growth of use within the company, or you're trying to meet specific technology deadlines that are out in the marketplace. So to summarize that first section of the presentation, the reason we measure HPC is so that we can make best use of the current capability and so that we can make the best decisions for the future capabilities. I'm going to move on now and talk a little bit about measuring performance. Does anybody know what that animal is that's on the screen? Peregrine falcon, which is the fastest animal on Earth. Except obviously it's not on Earth most of the time, it's flying above it, but anyways. That was my son's contribution to the slide deck, by the way. I was trying to find a picture to talk about performance, and he said, Peregrine falcon's the fastest animal. So there you go, that's how that slide got there. Technical performance. So when we talk about measuring HPC systems, most of us, being technically minded, will immediately jump to things where we're measuring the performance of the hardware itself, how fast the hardware runs. You have questions that come up like this. How fast is this supercomputer? How fast is my code? How well does my code scale? Which supercomputer or which system or which processor is faster? And all of these come down to a benchmarking exercise. By benchmarking exercise, or technical benchmarking exercise, we mean quantifiable data on the speed of the process of the system or the speed of the code. You might be measuring something like time. You might be measuring scalability. You might be measuring efficiency, something that you can assign some numerical value to, quantifiable data. In practice, that means running well understood, well-defined problems. So you take a piece of software you know runs. You take a test problem that you know what the results should look like coming out of that test problem. And you run that well-understood test case on a particular platform or on various platforms if you're comparing different platforms. And you record the data that comes out of it, the performance, the time, the speed, the scalability, whatever it is. It's also important to make sure that you have some specified conditions around that benchmarking exercise so that you have consistency between different comparisons on different platforms or comparisons of different codes or comparisons at different scale. Or if you're doing it in a procurement exercise, comparison between how the different bidders are sending you their benchmarking results. So the rules or the conditions are an important part of that. The trick, or the danger, if you like, is that we often measure benchmarking or benchmark systems, measure the performance for specific situations, but then we extrapolate or infer some other behavior or more general behavior based on those benchmarks. And then we make decisions based on those extrapolations. And so we like to believe we're making decisions based on hard data, but what we're actually making decisions on is extrapolations from the hard data. And almost nobody pays anywhere near as much rigor to those extrapolations as they should do in our experience in benchmarking exercises. So I mentioned benchmarking for procurements, which is one of the most common uses of benchmarking in the HPC industry. And I think benchmarking in the procurement sense falls really into three use cases. You can use benchmarking work to guide the procurement, to understand what the performance of the different technologies in the marketplace are, understand the performance of your code, the scalability of your code, so that you can inform how you're going to write that RFP before you write it, knowing that what you're writing is something reasonable that the market can deliver, and if you're buying a large system, your codes have a hope. Benchmarks are often used for acceptance testing as well, which is the bit where you get to ask the vendor to prove that what they've delivered to you is what they promised they were going to deliver to you in the bid stage. Or strictly speaking, what they promise they're going to deliver to you in the contract negotiation stage, which may or may not be the same as the bid stage. And all of that really is about driving value for money. It's trying to force the procurement process to be competitive based on performance metrics rather than some ephemeral sales discussions. And also it gives you some technical confidence that the system is going to do what you're hoping it's going to do, and it's going to deliver against the user requirements and deliver the performance to your end users. Benchmarking is fun, and I like to show this slide sometimes. A set of vendor performance results that are coming in your bid exercise, A through G. Are you trying to design a benchmarking process that excludes A and B from the rest of the discussions and then focuses on other means of distinguishing between C, D, E, F, G? Or are you trying to find a benchmarking process that narrows your discussions immediately down to F and G, the top two performing ones, and then use some other business criteria to decide between those two? And that affects how you set up the benchmarking exercise. However, it's not all about the technical performance. A lot of what you have to measure in HPC systems or HPC services in general, is the non-technical performance. How well is the HPC facility run? How well is it used? It can be very perfectly run, but no users, or likewise, it can be used very importantly, even if it happens to be run in a shambles. How fair is it? It comes back to this idea of fairness between the different users or the different people who are paying for different parts of the system if you've got multiple funding routes for the system. And then, of course, other things, measuring the cost of it, measuring the impact, measuring the benefits to the business, and we'll come back onto that in the next section. When we talk about the measurement of the service as a whole, we often focus immediately on the measurement of the utilization system itself. And this is one of the most common things that HPC services will measure as part of their facility is the utilization. And unfortunately, most people will default immediately to measuring the number of CPU cycles, the number of core hours used on the system, and that will become their metric, which may well drive the contract with the vendor, may well drive how they're measured from their funding in agency or the utilization of the system, therefore justifying the investment in the system and all the rest of it. Personally, I'm not a big fan of that, and I'll talk about that in a second. But even if you're going to stick to utilization as a metric, you've got other things in that system that probably cost more money than the CPUs and probably certainly get less attention on how well you're actually using them. So things like the memory, high-speed memory, or specifying a higher speed memory in the procurement process, are you actually measuring whether that was really used or not? The same is true if you've got a strong interconnect in there. Are you measuring the capacity of how those things are used? Are you measuring the network bandwidth? Are you measuring the resiliency features? If you've deliberately designed a system that has got a high resiliency requirement, you may be paying a significant premium, anywhere between 10 and 40% premium, to have a system that's engineered for high resilience. If you're not measuring whether your organization is getting any benefit from those resiliency features, why are you paying for them? Why not just get more nodes or whatever it is? Likewise with the memory, if you're specifying a lot of memory on all of your nodes of the system, and then you're confident that your users are using all of the CPU hours, but only 1 in 10 users once a week uses more than a quarter of the memory on the nodes, why have you paid for all that memory? Can you justify having all that memory for the occasional user who uses it? Sites are measured on how well, when we talk about a system's full or empty, or such a system has got such and such a utilization between different centers. Example I like to use is of a telescope. You measure a telescope not by how long your eyeball is glued to the end of it, but by how many stars it discovers. And we need to get into the same kind of mindset with HPC, and that the system is not necessarily delivering the best value to the organization just because it's full all the time, because the queues are very long and there's lots of CPU cycles being used. It might be true if you've got the rest of the process in place as well, that a full system is doing the right thing because you've got the processes to make sure the right users are on the system doing the right work. But you can't make an assumption that heavily utilized means delivering the best value. We also like to measure energy and power. They both roughly translate to cost, or readily translate to cost. It works out that the power capability of a system roughly translates to the cost of the infrastructure you have to put in place to manage the system in the first place. And energy is roughly the cost of the operation of the system on an ongoing basis, how much you're paying on a monthly basis for electricity bills. Both of those can be optimized, noting that optimized does not necessarily mean reduced. For example, if you're in a facility where you're not paying the electricity bill, the estates department is picking up the electricity bill for the computer, and you're in no way incentivized to reduce that bill through other means in your organization, then it may well be that you're incentivized actually to get a system that draws more electricity but delivers faster results through to the business users. So optimized does not necessarily mean reduced, although in most sensible organizations we'd like to reduce the overall cost of ownership, and that does mean reducing the electricity bill usually. And of course you can look at optimizing through hardware, but also through smarter software that uses the computer in a better way, more energy efficient algorithms and so on. And you also need to query whether you're measuring the energy of the facility itself to solve a problem, or the energy of a particular application on a particular problem, and optimizing between those two things might be different. If your system has some time where it's heavily loaded and some time it's not heavily loaded, then optimizing the energy cost of a particular application versus optimizing the energy cost of the facility as a whole may well give you different solutions. I talked about fairness and funding. As I said, that's a whole big theme in itself, but you might want to measure how you share the usage of the facility, the scheduling, priority, users who come up with an urgent requirement and so on, new users who come on board, how you allocate access to the system in the first place, how you review how a user has used the system over the year when you're considering next year's allocation. You might be trying to look at having measurements to support how the system is funded, noting that funding and charging out are not necessarily the same thing. You might have a block grant to buy the system, but then you might need to recharge that to the business units in a different way throughout the course of the year. And all of these things around scheduling, priority, charging, and funding and so on, they all affect the usage patterns, how the users use the system. The smart users will always try and gain whatever scheduling you put in place. And it also affects how you maximize the business impact. Are you trying to encourage certain kind of user behaviors or discourage other kind of user behaviors? And it comes back to this fairness thing that I keep mentioning. You'd also like to be able to measure how effectively the different teams involved work together. The networking team, the sysadmin team, the user support team, and all the rest of it. How do they effectively work together? How productive are they? How do they affect the happiness of the users and the service staff? Do you have the right organizational structures in place? How efficient are they? The governance and so on. So there's a whole load of stuff around just the HPC system that needs to be measured in a full service as well. And that's what this says here. Lots of things to measure. It's not just code speed. Measurement is a much bigger thing than that. And in fact, performance and measurement becomes a whole discipline in its own right. I talked about cost. And this is where I really do start trying to advertise my tutorial at SC16, because I've got a whole tutorial focused on, particularly on the cost elements, on Sunday morning at supercomputing. Here are some of the costs involved in running a HPC service. They're not all of the costs involved in running a HPC service. Clearly, there's all the hardware stuff that people like to talk about. You've got the computer itself, the storage, and so on. There's a whole load of other things in there. Cost of time, cost of resilience, we talked about. The effect of financing, cost of money over time, things like insurances, cost of documentation, the cost of commissioning the system in the first place, the project to commission it, the project to decommission it at the end of it, getting the users on board, migrating data on off it. All of these things all add to the cost of the overall HPC service. When you're talking about measuring the costs, you'll be glad to know I'm not going through all these boxes in detail, by the way. When we talk about the cost questions and you're building a cost model for your service, part of the questions that you need to answer in that process are looking at which of the costs you can control yourselves. Sometimes some costs you can control by making the decisions you make about the technology or how you operate the service. Some costs you can't control. Which costs does your own budget bear? In other words, which bit of it are you paying for, whether that's the capital for the system or the monthly leasing costs for the system, versus the costs that you don't bear. I used the example before of an estates department picking up an electricity bill. How are you incentivized against other costs that the organization bear that you don't bear directly on your own budgets? So, for example, if you deploy a system that's very, very cheap to run, but it causes your users a significant amount of cost to port to the system, are you incentivized? I mean, in that case, you almost would, because you'd have unhappy users. But are you incentivized against how the costs on other parts of the organization? And of course, you have to bear in mind that costs change over time in a nonlinear fashion. We like to talk about total cost. When we talk about total cost of ownership, it's really the total cost metric that the owners of the facility, the operators of the facility, like to concentrate on. to describe this as it costs money even if you have no users. In other words, having bought the system and providing data center space for it and support staff and electricity and all the rest of it, even if no users turn up, it's still costing you money. The other side of the total cost is the total cost of solution, which is what the users are interested in. What are all of the costs that I'm going to incur using this HPC facility for my project? That includes some costs that the service owners don't have to worry about, like porting and training of the users and so on. It also means that if I don't use the facility, it doesn't cost anything, even though the facility provider is still incurring costs. So costs, again, hopefully it's no surprise to anybody here, is much more complicated than just the price of the hardware. And you're really looking at this to understand what costs you can control so that you can optimize them. And I really rushed over it, but normally I like to have a much more in-depth discussion about the differences between optimizing against total cost of ownership and total cost of solution and how that affects the stakeholders in the process. And then finally, onto measuring value. And so we have another quiz question here. Does anybody recognize what that picture is? You should do. Go on. Now, bearing in mind I'm talking about value. Go. Oh, sorry, I thought you were going to tell me what it was.
Well, from what I can see, it looks like the wingtip of an Airbus airplane.
Oh, no. Oh, I thought you did better than that.
Oh, maybe it's
That is looking out of... That's a 787. So it's looking out of a window of a 787. What you're trying to do is generate a customer experience for the airlines so the airlines want to buy your plane and therefore make you money. So you've got to go down the value chain to not just how you're going to make money, but how your customers are going to get better value out of the product. And in this case, the better air quality, the larger windows, and the more efficient aircraft and all the rest of it all deliver value not just to the airline who's operating the product, but also to the customers of that airline who have a better experience flying it. So value, again, we come to these terms that are very common that I'm not necessarily a big fan of. I'm hoping everybody knows what return on investment is. You spend some money, you get some kind of return. Both of the terms are in a dollar. The investment cost, notwithstanding what I've just talked about a few minutes ago, in theory is relatively simple. How much are you spending? What's the CapEx, capital expenditure? What's the total cost of ownership? The return side of things is much more complicated and much harder to measure. It can be simple. We did less physical testing, therefore we saved this much money on physical testing because we did more simulations, and so that's a return for the business, a cost saving. It could be more advanced. Because we did more and more simulations, we have more accurate data for how the product behaves in service. Therefore, we can design it to a particular maintenance schedule, or we can size the maintenance team appropriately, and therefore we can save costs or make better costs there. It can be really quite significant changes to your business model. So, for example, the jet engine companies, Rolls-Royce, GE, and so on, now tend to rent flying hours to the airlines rather than sell them a jet engine. So they change their business model because they have more data about how the product actually performs over time, and they can take ownership of the maintenance issues. And some of that comes down to simulation and data management. The reason I don't like a return on investment is because it can end up being a little bit artificial in a whole load of different ways, but one of them was very perfectly demonstrated this morning when Earl was talking. Where we see a return on investment value of $673 per dollar investment or whatever it was, which is a wonderful figure, and I'm not disputing that it's a true figure for the investment you get back off HPC, but it's so divergent from the reality of ROI numbers that most organizations are used to dealing with that it becomes a very difficult conversation with finance officers. They essentially believe you're lying when you're talking about those kind of return on investment numbers. So ROI can be a really difficult metric. One of the other ways of measuring the value of the system is really looking not at pure cash terms, but looking at business impact. How does the business benefit overall? What are the business decisions or capability that's enabled by the HPC? Stop spending money on that part of the research project and move those resources into a different part of the project life frame or a different project option, and that improves the overall performance of the company. As I say, choosing the overall product direction, for example, could not do Project X without HPC. There are some things out there that you just can't do them without HPC, without simulation and management at scale. Weather forecasting, for example, is very difficult to do without HPC. It's not a question of whether you need HPC, it's just how much you need. Another one we've come across recently is attracting talent. HPC, so universities do all this all the time. As part of trying to attract a significant researcher to an institution, they'll deploy a HPC system to make it, to give them a facility to work with. We've seen the same in industry a couple of times. large organizations want to talk about the large HPC facilities they've got so that they become an attractive site for researchers to come and work at. And then obviously the business value that's generated as having those high-profile researchers on site will generate better R&D. So business impact is broader than just direct costings. You can try and ascribe costs to it, but it's really about your business quality and your business performance overall, not just a cost thing. So again, on value, return on investment is only part of the answer, and in my view, it's a relatively weak and small part of the answer. The value to business could well be binary. It could well be a yes or no. We could do this without HPC. We couldn't do it without HPC. Determining that value is hard. It's subjective. It depends upon what kind of conversations your stakeholders want you to have, whether you're talking to the CFO or the CEO or the marketing people or whatever, how you have to frame that value statement. There's no quiz on this picture. It's just a nice picture at top. So bring all that together. So measuring HPC, I believe, can be very powerful for the business and for the user. Quite often when we advocate better measurement, better metrics, and better reporting those measurements within companies, when we go and do consulting studies with companies, we feel nervousness about why does everything have to be measured? Users, why does everything have to be measured? If you do it well, it's very powerful. It helps the business understand what's doing. It helps to justify further investment. It helps to make things better for the users. It's complicated. It's hard work to measure performance. It's hard work to measure costs. It's even harder work to measure value. Getting it right, getting the right metrics, and putting the right amount of effort into measuring them, which in turn costs money itself to do that process, is difficult. And as I said, I talked about measurement, but I didn't even touch on reporting, which is about how you disseminate it back into the business and how you make the best use of reporting back into the business and reporting back to the users and engaging with stakeholders. That's a whole separate discussion. And I did promise you several adverts for my tutorial at supercomputing, and so that's up there again on the slide as well. And with that, I'd like to finish and take questions.
So do you have any recommendations on, you talked about optimizing your system, right? Well, my experience has always been that optimizers were great tools at finding the weakness in whatever system you were looking at, because if there's a flaw in it, the optimizer will exploit it to the high heavens. So you got any recommendations or guidelines on how people should consider what cost function they're going to use to measure their data center and optimize it on?
Yeah, but that's not. I can't answer that in the time we've got available. Yeah, I mean, there's a whole business. A lot of that depends upon the culture of the organization. It's not the same for different organizations. It comes back to those questions I said before about which costs are inside your control, how you're incentivized against those, what level of complexity you have to go to. So I had that slide where you have loads and loads of different costs on the screen. How many of those costs do you actually have to take account of, and therefore how complex does your TCO model have to be in order to make the decision you have to make on it? And if your decision is optimizing the use of your facility, how optimized does it have to be? Are you trying to extract the last 2 or 3% out of the facility, or are you just trying to get it to within 30% of what is optimum? And those all affect how you do that, go about that process.
Andy, thank you.
Thank you.